Okay, and now we're going to do some more equations of quadratic functions, and this is example 3, and this is a little more tricky. Okay, we want to find the equation of a parabola that passes through these 3 points, negative 1, 11, 1, negative 1, and 3, 3. So we're going to use our standard form. And what we're going to do is we know that if it goes through this point, negative 1, 11, then that's going to be the x and y. So now I'll rewrite this, and every time I see a y, I'll put 11, and every time I see an x, I'll put a negative 1, and try to get an equation in terms of a, b, and c, and we're going to do that for all 3 points, and we'll have 3 equations with 3 unknowns, and we'll have to solve those. And sometimes those are a little bit more challenging to solve, so this is going to be 11, y is 11, that equals a, and x is negative 1, so negative 1 squared, plus b times negative 1 plus c. And if we square this, we end up with let's write this on the left. So what's negative 1 squared is 1, so that's just going to be a. And negative 1 times b is negative b. And plus c. And that equals 11. And we're going to call that equation 1. And then we'll do the same thing with the other points. So we have 1, negative 1. And again, this is x and y. So every time I see a y, I put a negative 1. So there's a y here. Again, we're going to use this standard form. So I'll put a negative 1 here, and that's going to equal a times 1 squared plus b times 1 plus c, and that's going to imply, or that's going to lead to this conclusion, a plus b plus c equals negative 1. And I'm going to call that equation number 2. And then again, last point, 3, 3. Again, this is x and y, so every time I see an x, I'm going to put 3, and every time I see a y, I put a 3. So this is going to be 3 equals a times 3 squared plus b times 3 plus c, and that's going to lead to this conclusion that this is going to be 9a plus 3b plus c equals 3. And I'll call that equation number 3. I got to go back and review how do we do 3 equations with 3 unknowns. So equation 1 looks like this. A minus b plus c equals 11. Equation 2 looks like this. A plus b plus c equals negative 1. And equation 3, I did some examples earlier on 3 equations. I think I did 1, so you can take a look at that. Equation 3 is 9a plus 3b plus c equals 3. So those are your 3 equations. And now it looks like we've got a lot of matching. So whenever you have matching or zeros, use those equations. So I'm going to take equation 1. I'll just write it down here. Here's equation 1. A minus b plus c equals 11. I'm taking equation number 2, and I'm going to multiply everything by negative because I can get rid of 2 variables. So it's like a twofer. So I'm going to multiply this by negative 1. So it's going to be negative a, negative b, negative c equals, and a negative times a negative is a positive 1. And I'm going to add those up. And negative a Positive A can't become 0. Negative C becomes 0, and negative B is negative 2B. That's like a new equation, equation 4 I can call it. And that equals 12. So if I divide both sides by negative 2, B equals negative 6. Now that B is the B part of my equation, so that's going to go right there, negative 6x. Now, I can go back to any of these equations, so let me take equation 2 over here. Equation 2, and I'll put that negative 6 in for B, so equation 2 will be A, and instead of minus B, or I'm sorry, A plus B, instead of A plus B is going to be negative 6. So I'll put plus B, negative 6 there, because B is 6. And then plus C equals negative 1. And then I'll simplify this, so that's just going to end up giving me A plus C equals, and if I add 6 to both sides, 6 minus 1 is 5. Then I'll take equation number 3, and I'll also put that value in. So 9A plus 3 times, and B was negative 6. Plus C equals 3. And then I have 9A, and this is going to be negative 18, plus C equals 3. And then if I add 18 to both sides, I have 9A plus C equals 21. And that's equation 3. These are all equation 3. So now I'll take equation 3, and then I'm going to take equation 2, and I'm going to multiply by negative 1, and my C's will go away. So I'll take equation 2. This is the new form, I guess. And I can multiply that by negative 1. And if I do that, I have negative A, negative A, negative C equals negative 5. And if I add those up, what happens to my C's? They become 0. So now I have a new equation. I guess I can call this equation 5. And this is going to be 8A equals 21 minus 5 is 16. So if I divide both sides, I get A equals 2. Now I got A and B, and I can put those in any of these equations to find C. So I can go back to equation number 1, I guess. And A is 2, and B is negative 6. So I'm sorry, 8 minus negative 6 plus C equals 11. So there's my A. A is 2. B is negative 6. So that's going to be 2, and then plus 6 plus C equals 11. And then that's going to be 8. So if I subtract 8 from both sides, C will equal 3. So there's your C. Oh, sorry, there you go. Okay. So again, I put this in equation number 1 over here. 2, A is 2, minus B, which is negative 6, plus C, which is what I'm trying to find, equals 11. Negative times the negative is positive. 2 plus 6 is 8. 8 from 11 is 3. And then we go back and put this in the standard form. Y equals, or f of x, whatever your pleasure is here. Y equals ax squared plus bx plus c. So in this case, y will equal. And a is what? 2. So it's going to be 2x squared. Oh, plus b is negative. Sorry about that. So negative 6x. Just change that real quick here. And c is 3 plus 3. So there's your equation. 2x squared minus 6x plus 3. And you can check any of these points. If you put any of these 3 points in, x, y, x, y, x, y, if you put that in for the x and the y, the left side will equal the right side. Oops, sorry. The left side will equal the right side for any of those 3 points, because they're all in the parabola. Okay? So that's a little more complicated. So be very careful on those, and make sure that you label your equations and you'll keep track of everything.